Hello guys, how are you today? So today I'll be explaining the topic 2. Topic 2 is not only hydrogen. Topic 2 is hydrogen, oxygen and air in one. They put the hydrogen and oxygen in the same PDF, but the air is in a different one. So what I'm gonna do personally in this video is I'm gonna be explaining hydrogen, oxygen and air. For the questions, I will open the CQD so you can find them on the topics course revision questions. And yeah, that's pretty much it. So let us start with topic 2, hydrogen. Laboratory preparation of hydrogen. So the first thing they're telling us is how to prepare hydrogen in the lab. Usually we have two methods. The first method is the reaction between a metal and a dilute acid, or the second method is called the methane steam reaction. Now, another way that is not mentioned in the slide but is mentioned in the course question documents, it is by the addition of steam to a metal. So when you add steam to a metal, okay, it is gonna form hydrogen. This we will learn it in topics 10, which is about metals. So I will explain topics 10 later on, or like by the time I would have posted this video and you guys used it to study, I probably would have posted it, hopefully. But another way is the addition of steam to a metal. So steam plus a metal will produce hydrogen. But the main ways they want us to know is what? The reaction between a metal and a dilute acid. Okay, and then the second way is the reaction of methane steam or a methane steam reaction. So let us read about the reaction between metal and dilute acid. Hydrogen is usually made by the reaction of zinc or magnesium with dilute sulfuric acid. Now, dilute means that it's not concentrated. Like, it is concentrated, but its concentration is little. So we're going to write little concentration. Okay? And then they gave us an example. An example is magnesium, the metal Mg, in addition to sulfuric acid, which is H2SO4, is gonna give us magnesium sulfate, which is MgSO4 aqueous, in addition to hydrogen gas. So again, remember, if you cannot like memorize the equations, what I would do personally is I would write a general format. So we are taking a metal, okay, so the general format is gonna be metal in addition to acid, okay? So metal in addition to an acid, and this acid is dilute, okay? It is gonna form for us a salt, which in this case is magnesium sulfate, and in addition to hydrogen gas. So keep this as the general formula. Metal plus acid will give us salt plus H2 gas. And let us try for the zinc. So zinc, which is the N solid, in addition to the acid, which is H2SO4 aqueous, okay? They will react to give us a salt, which is the ZnSO4 aqueous, okay? In addition to H2 gas. So as you see, if you have a general formula or a general format in front of you, it's gonna become way easier. Okay, we move on to some notes. So in the notes, they told us that potassium, sodium, lithium, and calcium all react violently with dilute sulfuric acid and dilute hydrochloric acid. So it's dangerous to put all these metals into an acid. So pay attention. They told us that potassium, sodium, lithium, calcium, remember these four metals, they all react violently with dilute sulfuric acid and dilute hydrochloric acid. So it's dangerous to put these metals into an acid. But another way to make hydrogen out of these four metals is not by using sulfuric acid, but instead of using the acid, we will use steam. Okay, we can check it in the 10 topics about the metal. Now, metals below hydrogen in the reactivity series, being copper, silver, gold, and platinum, will not react with dilute acid. So, let me get just what is the reactivity series. So over here, this is a very important reactivity series. If you guys could like screenshot, okay? It's very important to keep in mind. And also they have for us like the separations with what they will react, okay? So as we said before, We have 4 main ones that they told us about, so I'm just gonna cross out the ones that we don't need to know. These two we don't need to know, but the metals we need to know about, they are potassium, which is K, sodium, which is Na, lithium, which is Li, and calcium, which is Ca. They have a very high reactivity, so if they react with acids, it's going to be very dangerous. That's why we react them with steam. Okay? Now, if you go down, everything here is like less reactive than the metals above, so you could react them with acids to produce steams. And then finally, anything under hydrogen is never gonna react with anything. So they are very highly unreactive, so you cannot use them in any equation. Alright, this is just the reactivity series and what you need to know about it. Alright, so now we will move on to the industrial preparation of hydrogen. Reaction of methane and steam. Hydrogen is obtained from methane, which is a natural gas, okay? Based on topic 5, methane, what is its group? This is just a random quiz. I'll give you guys like 10 seconds to answer and then I'll give you the answer. Now, if you said that methane is in the group of alkanes, or its homologous series is alkanes, you are correct. Good job. Okay, and we know that alkanes, it is what? It is a hydrocarbon. If you remember, its formula was CnH2n plus 2. So, very simply, this is just like all you need to know about the hydrocarbon methane. Okay, so the hydrocarbon, an organic compound that contains carbon and hydrogen only, is reacted with steam. So you will take methane, which is our hydrocarbon, which is CH4 gas. You will add to it steam. Now pay attention, steam is water but a gas, so it's going to be H2O, but not liquid, it's going to be gas. It will produce two gases, which are carbon dioxide gas and hydrogen, okay? So methane plus steam will form carbon dioxide plus hydrogen. Now, where do we use hydrogen in real life? Some people use hydrogen as a fuel, which is a very important process. Hydrogen can be used directly as a fuel for cars or used in a fuel cell to produce electricity. Hydrogen reacts with oxygen to produce water plus energy, etc. The reaction you need to know is that hydrogen plus oxygen will give you water, and then you balance it and do not forget to put the energy. The energy released by the reaction can be used to run a car engine, which is similar to, but not the same as car engines which burn petrol. Okay, so if they ask you for the reaction, it is 2H2 gas plus O2 gas will give us 2H2O liquid plus energy. We move down to the advantages of using hydrogen as a fuel. Hydrogen can be made from the electrolysis of water if the electricity used during electrolysis comes from a renewable resource, solar power for example, then the hydrogen fuel produced is also renewable. Hydrogen used as a fuel does not produce pollution or contribute to global warming because the only product of combustion is water. So these are just some advantages of having hydrogen as a fuel, whereas disadvantages of having hydrogen as a fuel. Hydrogen does not contain a lot of energy compared to petrol per gram. So that's why we will need a bigger amount of hydrogen to run a similar car. Okay, also hydrogen is explosive. When it reacts with a lead splint, you need to remember that it makes a popping sound. Okay, so hydrogen is explosive. And being a gas is difficult to store. If the hydrogen does not come from a renewable resource but is made from methane, then the hydrogen fuel produced is not renewable. So this is all you need to know about hydrogen based on this over here. I feel like some information is missing. Okay, I think they might be in the air paper. We'll see, because I didn't check the air paper. But anyways, let us move on to topic 2, which is oxygen. Okay? Occurrence and percentage of oxygen in the air. What do we need to know about oxygen? First of all, oxygen has two allotropes, being oxygen O2 and ozone O3. Oxygen is something we breathe, and ozone, it is a layer that protects the earth from the sun. Like the molecules of ozone, which is O3, they can be found in the ozone layer, which is used to protect the earth from the harmful rays of the sun. Now, oxygen, its percentage by volume of the air is 21%. So if they ask you how much is the percentage of oxygen in the air, it's 21%. And However, if they ask by mass, then it's 23%. So the volume of oxygen in the air is 21%, but the mass of oxygen in the air is 23%. Now, how do we prepare oxygen? We prepare oxygen in the laboratory, of course. And then we have the other method, which is industrially. So you can prepare oxygen in the laboratory by catalytic decomposition of hydrogen peroxide. Catalytic decomposition means that it involves a catalyst. Okay, you should know that the catalyst used, it is called manganese IV oxide. Okay, so our catalyst is manganese IV oxide, or MnO2. Now the equation you need to memorize is that hydrogen peroxide will give us water plus oxygen. If you cannot memorize the balancing, just memorize what is hydrogen peroxide. It is H2O2. Using the catalyst MnO2, it will give us what? It will give us water, H2O liquid, in addition to what? In addition to O2 gas. But as you can see, it is not balanced. So to balance it, you're going to put a 2 over here and a 2 over here. Okay, now we move on to the last process of obtaining oxygen, which is the industrial process. It can be obtained industrially by fractional distillation of liquid air. So how do they liquefy air? They liquefy air by putting it at a really, really low temperature, probably lower than its boiling point, so that it will become a liquid again. And then, yeah, that's pretty much it. Now here they said nitrogen with a lower boiling point. So nitrogen has a lower boiling point than oxygen. When it is a liquid, they will slowly start to increase the temperature a little bit more. So it has a lower boiling point than oxygen, so nitrogen will evaporate first. Okay, and then it will leave the liquid oxygen as a residue at the bottom of the tower. And then that's how you obtain oxygen using the industrial method. So this is from this paper. Let me open the air paper. So here we reach topic 2, air. Now we're going to discuss about air, just some things that involve also hydrogen and oxygen, but mainly it's going to be about air in general. Composition of clean, dry air. How do you what is the composition, or what is clean dry air made up of? So based on the table, we can see that nitrogen is 78% of the air by volume, of course. Oxygen is 21% of the air by volume, and then the remainder is noble gases and carbon dioxide. To calculate the remainder, very simply, you're going to do 78 plus 21%. You will get it to be 99%. So out of 100% of air, only 1% is noble gases and carbon dioxide. So usually, how do you separate nitrogen and oxygen, as we discussed previously? It is achieved by the fractional distillation of liquefied air. How do we liquefy air? We lower its boiling point to as much as we can, and then we slowly start to increase it until the nitrogen will evaporate and you're left with liquid oxygen. Okay, that's pretty much it for here. We move on to air pollutants. Here we have different types of air pollutants, and we are going to be discussing their sources. The first thing we start with is sulfur dioxide. Sulfur dioxide, you will obtain it from the combustion of fossil fuels which contain sulfur compounds. So the combustion of fossil fuels, which happens mainly in cars that require like petrol, gas, all of these types of things, they will create sulfur dioxide, okay? The gas is sulfur dioxide being produced from the combustion of fossil fuels. You can also see, not only in cars, but also a lot in factories, they produce a lot of sulfur dioxide. Then, the oxides of nitrogen, you will get it from car engines. So, the car exhaust fumes, they contain what? They contain the oxides of nitrogen. Remember, the combustion of fossil fuels, this is sulfur dioxide. However, the car exhaust fumes, they contain oxides of nitrogen, meaning nitrogen monoxide, nitrogen dioxide, whatever. So now we move on to what? To carbon monoxide and particulates. Okay, what you need to know, whenever you see carbon monoxide directly, it is incomplete combustion of carbon. Okay? However, whenever you see carbon dioxide, it is the complete combustion of carbon, okay, containing fossil fuels. Now, finally, methane. Methane, you can get it in two ways, and usually it's from nature. So usually the decomposition of vegetation and waste gases from digestion in animals, especially the cows. So, sulfur dioxide, you will get it from combustion of fossil fuels. Oxides of nitrogen from the car exhaust fumes, not fuels, fumes, like the gases. Carbon monoxide, the incomplete combustion of carbon. carbon dioxide, complete combustion of carbon, and then methane, decomposition of vegetation, and the waste gases of animals. We move on to the adverse effects of each pollutant. How does each pollutant affect our environment in a bad way? Sulfur dioxide. It is a poisonous gas that irritates the lining of respiratory tract, causing breathing difficulties. So, the sulfur dioxide, which is formed by the combustion of fossil fuels, is a poisonous gas that irritates the lining of respiratory tract, causing breathing difficulties. It also causes acid rain. Alright, now, the oxides of nitrogen, how do we produce the oxides of nitrogen from the car exhaust fumes? It causes also acid rain. However, it contributes to photochemical smog. Smog is like I don't know if it's thicker or thinner, but it's like a type of fog. Like fog, F-O-G. So let's say it's a thicker version. So smog is a thicker version of fog. Okay, and this is very dangerous, especially in the mountains or like when people are driving on the highways. This is very dangerous to experience smog. And it also causes respiratory problems. So now we just finished discussing sulfur dioxide and oxides of nitrogen. We move on to carbon monoxide, which is produced by the incomplete combustion of carbon. It is what? It's a toxic, poisonous gas which binds to hemoglobin to form carboxyhemoglobin that binds to the red blood cells and reduces the ability of red blood cells to carry oxygen, leading to asphyxiation. I don't know how to say it. Asphyxiation, something like this. So basically, what you need to know from here is hemoglobin. It's something very vital you find in your red blood cells, and it helps in the transporting of oxygen to all your body parts, because when you breathe, you need to like have oxygen move to all parts of your body so that you will be able to undergo aerobic respiration, okay? However, if you take in carbon monoxide, it will replace the hemoglobin. It will be like you will not be able to move the oxygen anymore in your body, and like it will lead to suffocation in some sense. All right, and that's the discussion of carbon monoxide. Particulates. How do you deal with what do particulates deal, or what do? They increase the risk of respiratory problems, and they increase the risk of cancer. Okay, and then finally carbon dioxide, which is produced by the complete combustion of carbon, and methane, which is produced by the waste gases of animals or the decomposition of vegetation. Both of them have the same result, which is at higher levels, they will lead to increased global warming, which has adverse effects on the environment as it changes the climate. So, actually, these two gases, there's another one which is called the CFC gases, the chlorofluorocarbons, okay, with the carbon dioxide and methane. These three gases, they all lead to something called the greenhouse effect, which we're gonna learn about it, I believe, now. No, well, not now, but just like in a little bit. So here is like a small summary of everything we talked about. Carbon dioxide, you obtain it from complete combustion of carbon-containing fuels, and it leads to higher levels of CO2, which will lead to an increased global warming, which leads to climate change. Then carbon monoxide and particulates, you obtain them from the incomplete combustion of carbon-containing fuels. Carbon monoxide is toxic, okay? It will not allow oxygen to spread to other parts of your body, and particulates increased risk of respiratory problems and cancer. Methane, you obtain it from the decomposition of vegetation and waste gases from digestion in animals, whatever. And then it leads to higher levels in global warming and etc. Oxides of nitrogen, you obtain them from car exhaust fumes or car engines. They give us acid rain, photochemical smog, and respiratory problems. And then finally sulfur dioxide, which is the combustion of fossil fuels, and then you will get acid rain. Now we will discuss photochemical smog. It occurs mainly in areas that have large numbers of automobiles. So definitely, we said that smog will come from oxides of nitrogen, and oxides of nitrogen come from car engines. So definitely more car engines means more oxides of nitrogen, means more photochemical smog. Funnily enough, here pay attention, it involves no smoke or fog. It's not smoke, it's not fog, but it's something similar to a fog. So like it's a thicker version of fog, how I would explain it. Actually, let me just search it up and show you. It looks something like this. So as you can see, it's like, it's not fog, but it's just like similar to fog in a sense, you know? Alright, it is the result of photochemical reactions. So, reactions catalyzed by sunlight between nitrogen oxide and unburnt hydrocarbons and nitrogen monoxide to produce nitrogen dioxide, which is brownish. Okay, so very simply they said that these two reactions, which is nitrogen oxides react with unburnt hydrocarbons catalyzed by the sunlight, okay, it will produce ozone gas, which is highly toxic. Us as humans, we're not supposed to breathe it. That's why it's only found in the ozone layer. And the other reaction is nitrogen monoxide, which is catalyzed by sunlight. It will produce nitrogen dioxide, which is brownish. Okay, the resulting smog, what are the side effects of smog? It is a light brownish coloration of the atmosphere, which reduces visibility, causes plant damage, causes eye irritation, and causes respiratory distress. Now we will move on to acid rain. So how does acid rain form? Acid rains when sulfur dioxide reacts with water in the air, it will form sulfuric acid, which is an acid. So imagine like you're walking outside, it starts raining acid. That's very dangerous. Also, when oxides of nitrogen react with water, they form nitric acid. So the rain becomes acidic. Why? Because you have sulfur dioxides and oxides of nitrogen reacting with water to form sulfuric acid and nitric acid, which is not nice at all. It will form then acid rain. And then we know that natural rain is slightly acidic due to dissolved carbon dioxide, which has a pH around the 5.5. It's not too acidic, but at the same time, it's not neutral, okay? Whereas when it is acid rain, it drops all the way to a pH of 4, which is very, very dangerous, okay? It's very acidic. Now, what are the problems caused by acid rain? Corrosion of metal structures. Yes, of course, acid plus metal, it will corrode. Then there's damage to buildings and art statues. Acid rain reacts with carbonate in marble and limestone, leading to the erosion of the stone buildings and statues. Then it causes increased acidity of water masses. So if it goes in a lake, it will cause the lake to become acidic and it might kill the fish and other aquatic life. This is very important. The acidic rain, okay? Usually normal rain will not do this, but acidic rain will wash aluminium into water bodies. And this aluminium, if it will wash into the water bodies, it's toxic and it will kill the fish. It damages plants that take in acid rain, leading to their stunted growth and eventually death. Yes, it could like make them grow weirdly and then they will die. And finally, acid rain enhances leaching of vital minerals out of the soil. So leaching means that they will go out of the soil into bodies of water, and because the soil doesn't have these minerals anymore, it will cause the death of trees. So in general, yes, it's very dangerous. Now, why should we decrease the emission of air pollutants? Because first of all, it's to stop these issues. Now, to actually decrease their emission, it's not going to be easy. Why? Because it's going to be expensive. You'll need to look for a substitution for these gases, okay, or like the things that are producing these gases. And for two, the rain most often falls in the areas further away from where the gases were emitted. So it will be very difficult. Like if you were to move the whole industry to another place alone, it would still be very difficult because like the rain will form in areas further away from where the gases are emitted. So you have no clue on how to protect the citizens and the area. Okay, now here is where I was talking about the greenhouse effect. So we will start with carbon dioxide, greenhouse gases, and global warming. Carbon dioxide and methane are greenhouse gases that cause global warming. So carbon dioxide, methane, and another gas which is called the CFCs, the chlorofluorocarbons, okay, they are very like also greenhouse gases, okay, they also cause global warming. Global warming is the increase in Earth's temperature due to the increase in the amount of greenhouse gases in the atmosphere. This rise in temperature affects the climate all over the planet in ways which are hard to predict. Some areas may become wetter or drier, other areas may become hotter. The main predictable directions of wind and ocean currents may slow down, speed up, or change direction. This could have catastrophic consequences for life on planet Earth, including rising sea levels because of ice melting at the poles, and more extreme weather because of more convection in the hotter and wetter atmospheres. So basically, in summary, just like how I would understand the greenhouse effect. This is our Earth, yeah? These are like the continents. Sorry if I drew it wrong. There we go. Just like say this is what Earth looks like now. And then we have the sun coming from over here, and it will emit its light rays. As we know, its light rays, it has like white. Usually it is white. So the light rays of the sun are white. And we know that they also have different colors. So these colors can be like the colors of the light refraction. We have mainly the ultraviolet, the infrared. You can check them online. Okay? So mainly what happens now, usually what's gonna happen is that the sun will emit the light. It will reach the planet Earth and then it will bounce back up. This is due to the ozone layer. So like it will bounce back up. Why? Because if it stays on the Earth, then gradually the Earth's temperature will increase, and this could cause the drastic changes. Alright, and the two light rays we want to focus on, they are what? They are infrared and the ultraviolet. Now, usually the ultraviolet rays, they bounce off the Earth very quickly. Like they will go hit the Earth and they will bounce back up. Whereas, so let's say this is the ozone layer, okay? We have the ultraviolet light, it will go up and like it will heat the Earth and it will bounce back up. Okay, or like actually it will go to the ozone layer and it will bounce back up. Okay, so this is the ultraviolet. And for the infrared, I will now use the blue. However, the infrared, because of the amount of like methane, carbon dioxide, and CFCs, what's gonna happen is that the infrared, instead of bouncing down and bouncing back up, it will bounce and it will enter the Earth, which is not something that we want because it's gonna increase the temperature of the Earth. So in here we have these particles. Let's say these are the particles, whatever, of carbon dioxide, methane, just like random particles in here. Usually, what's happening? The infrared, it will bounce. It will hit the Earth and it will bounce back up. So it will heat it and it will go back to where it was. Whereas the infrared, it will be trapped by these particles, which are carbon dioxide, methane, and CFCs. So instead of just like bouncing and going back up, it will just like enter directly straight into the Earth, which will gradually increase its temperature. And we call this global warming. Now, we call this the greenhouse effect because it's similar to how a greenhouse works. If you've ever seen like a greenhouse, like, you know, those houses made out of glass with the plants in them and whatever. These are the plants. Yeah, they will stay. Okay, so it's the same concept. The infrared will come, hit the plants and bounce back up. Whereas the glass is so thick that, not the infrared, sorry, the ultraviolet, it will bounce, hit the lights and bounce, hit the plants and then bounce back up. Whereas the infrared, because the glass is so thick, it will just bounce and stay inside of the area and it will keep the plants warm. So this is why we call this the greenhouse effect. Alright, so that's pretty much it for the greenhouse effect. Let's read over here. The greenhouse effect, the temperature of our planet is a result of balance between the amount of heat it receives during the day from the sun and the amount it releases out at night into the space. So, during the day, energy from the sun reaches the earth in the form of electromagnetic radiation. The surface temperature rises during the day and at night it cools down. Okay, this heat is lost in the form of infrared radiation, but usually because of the greenhouse gases now, the infrared is not allowed to bounce back up. Carbon dioxide and methane, which are the greenhouse gases, they absorb infrared radiation that would have been reflected back to space during the night and traps it in the Earth's atmosphere. The more gases in the atmosphere that absorb infrared radiation, the more heat is trapped and the less thermal energy is emitted back into the space at night. The overall effect is that the Earth receives more heat during the day than it loses at night, so its temperature will rise, which is drastic. We don't need that. Now we move on to the oxides of nitrogen. When fuel burns in car engine cylinders, a huge amount of energy is produced, which increases temperature and pressure tremendously. Yeah? Under these, oh, look at this. These is very funny. Under these elevated temperature and pressure conditions, oxygen and nitrogen gas react, forming nitrogen monoxide, which further reacts with oxygen to produce nitrogen dioxide. So how do we reduce the effect of air pollutants? We have a strategy. The first way is to plant more trees, because the trees will absorb carbon dioxide and they will release more oxygen. Then reduce livestock farming, because the livestock will have methane. They will release methane. Methane is something that is a hydrocarbon, it will release methane. And then decrease using fossil fuels by alternative renewable energy sources such as hydrogen, renewable fuels like wind, solar, water, whatever. Then strategies to reduce acid rain. How do we reduce acid rain? We need to reduce, first of all, sulfur dioxide. To reduce sulfur dioxide, we have, we have a few ways to reduce the emission of sulfur dioxide. So what are these strategies to reduce acid rain? The first strategy, as we discussed, was to reduce the sulfur dioxide. And to reduce the sulfur dioxide, we need to do flue gas desulfurization systems. Okay, and they usually put this in power stations and factories. Okay, they put the flue gas desulfurization systems. Now these systems, they remove the sulfur dioxide and nitrogen oxides and particulates from flue gases. These systems have lime scrubbers, which is the calcium oxide CaO, to react with the sulfur gas, the sulfur dioxide gas, and it will produce CaSO3. This is literally an acid-base reaction. So calcium oxide, in addition to sulfur dioxide, will produce CaSO3. Okay, another way is to use low sulfur levels, and the third way is to use catalytic converters in vehicles. Okay, since the early 1990s, car exhausts have been fitted with catalytic converters. Now you should know that catalytic converters, they have transition metals in them. Okay, these are one of the properties of transition metals. These use transition metals such as rhodium, palladium, platinum, etc. to convert harmful emissions into less harmful substances. Okay, now catalytic converters, they minimize the release of the following gases. These gases are carbon monoxide, which is converted to carbon dioxide. Okay, then the oxides of nitrogen, which are then converted to nitrogen, reduced by the carbon monoxide. And then finally, hydrocarbons, they will react with oxygen and they will form carbon dioxide and water. Now, if they asked us for the typical reactions, what you would need to memorize are these these four basic reactions. Okay, the first reaction is that carbon monoxide gas is added to oxygen gas to produce carbon dioxide gas. And of course, you can balance it. The second reaction is that the carbon monoxide gas will be added to nitrogen monoxide, okay? And this will form what? This will form carbon dioxide in addition to N2 gas. However, if we are dealing with nitrogen dioxide, not nitrogen monoxide, we would need to add 4 CO to produce, again, carbon dioxide and nitrogen gas. Okay, and then finally, hydrocarbons plus a nitrogen monoxide will produce carbon dioxide and nitrogen and water. So again, the reactions are carbon monoxide with oxygen will produce carbon dioxide. Then carbon monoxide with nitrogen monoxide will form carbon dioxide and nitrogen. And then nitrogen dioxide with carbon monoxide will form carbon dioxide with nitrogen. And then finally, hydrocarbons plus nitrogen monoxide will form carbon dioxide and nitrogen and water. Keep these in mind and do not forget to balance them. Now, here, catalytic converters have a large surface area. Keep in mind, they have a large surface area and they work best at high temperatures. Okay, so look, here you could have the oxides of nitrogen, the carbon monoxide, the unburnt hydrocarbons. They will all enter into the catalytic converters. And here you have the transition metals such as rhodium, platinum, palladium, whatever. And then they will produce less harmful gases to the atmosphere. Okay, and they said, keep in mind and note, catalytic converters are poisoned in the presence of lead. So lead should not be part of the catalytic converters. We'll move on to now the processes which use the gases carbon dioxide and oxygen. We have the two main processes, which is photosynthesis. What is photosynthesis? Photosynthesis is the process by which plants make their own food. How do they make their own food? They absorb carbon dioxide from the air. with water from the soil in the presence of chlorophyll and sunlight, okay, and then they will produce glucose, which is sugar, and oxygen. So to remember their formula, it is 6 carbon dioxide gas in addition to 6 H2O liquid is gonna give us in the presence of sunlight energy and chlorophyll, it's gonna give us glucose, C6H12O6, which is a solid, in addition to 6 oxygen gas. So 6 CO2 gas will plus 6 H2O liquid plus sunlight in the presence of chlorophyll will give us C6H12O6 solid plus 6 O2 gas. Now, respiration is the complete opposite of photosynthesis. So as you can see, they will flip. The reactions will flip. So look, the C6H12O6 solid is here, 6 CO2 is here. It will become 6 CO2 gas plus 6 H2O liquid plus energy. Okay, so again, respiration is the process of burning food to produce energy. In the process, carbon dioxide and water are produced. Okay, so in photosynthesis, carbon dioxide plus water in the presence of sunlight and chlorophyll will produce glucose and oxygen, whereas in respiration, it's glucose plus oxygen will produce carbon dioxide and water and energy. Now, they said photosynthesis is an endothermic process. It's endothermic because it has energy on the reactant side, and then respiration is an exothermic process. It's exothermic because it has energy on the product side. Now, this is it for this sheet, topic 2 air. I'll move on now to the CQDs. Now, I have no clue why everything is highlighted, so just like bear with me on what this is. We'll just write the answers aside, okay? So, the first thing, okay, the first question is about hydrogen. Now, some questions here, they were not put in the notes, like the notes paper, so I think these are very important to focus on. So in part 1, they said, describe how to test for the release of hydrogen gas in an experiment. We know that hydrogen gas makes a popping sound anytime it is exposed to a lit splint. So what you need to write is that hydrogen gas makes a distinctive popping sound when it comes in contact with a lit splint. That's all you need to say for the first question. For question number 2, they said write the equation of the reaction of lithium with liquid water. So for part A, they said they need lithium with liquid water. Lithium, we know that it is Li solid. It is reacting with liquid water, so H2O liquid. What you need to know is that when a metal will react with a liquid, it will form a base, okay, in addition to hydrogen gas. So this base, it's going to be LiOH in addition to H2 gas. Now, as you can see, it's like not balanced. So to balance it, you're going to put a 2 next to the Li, a 2 in front of the H2O, and a 2 in front of the LiOH. And do not forget that LiOH, because it's a base, it's still going to be aqueous. Okay, it's actually a salt, not a base. But it's like a basic salt. So keep in mind always that metal, in addition to water, it's gonna produce a salt, and in addition to hydrogen gas. Okay, so that is part A done. We move on to part B. Write the equation of the reaction of magnesium with sulfuric acid. Magnesium is Mg solid. It will react with sulfuric acid, which is H2SO4, and H2SO4, because it is a solid, an acid, it's aqueous, okay, and it will produce for us a salt in addition to hydrogen gas. Now let us find out what this salt is. If you are getting rid of the H2 gas, it will come over here, and the salt is gonna be MgSO4, and it is aqueous. Now here everything is balanced, so always keep in mind that metal plus acid is gonna give us a salt plus hydrogen gas. So metal plus liquid water is gonna give us a salt and hydrogen gas. Also, metal plus acid is gonna give us a salt plus hydrogen gas. And then for part C, in part C they said write the equation of zinc with steam. Zinc, which is a metal, in addition to steam, H2O gas, so it is steam, it will form what? It will form zinc oxide in addition to steam. So zinc, Zn, the metal, will react with H2O, steam, to produce what? To produce the zinc oxide, so a metal oxide, which is a solid, in addition to hydrogen gas. Now these, we would have learned all of these in what? In chapter 10 notes, which is about the metals. Okay, so keep these in mind, that we will learn about these in chapter 10 notes, which is the metals. Okay, so now we move on to part D. In part D, they said consider the process of electrolysis. Name two gases that are produced when the brine is electrolyzed. When brine is electrolyzed. Now, what exactly is a brine? Brine, it is usually a particularly highly concentrated water solution of common salt. Usually they will use the salt NaCl. So brine, it is a concentrated salt, NaCl. It is undergoing electrolysis, and we know that if you separate them into their ions, Na plus and Cl minus, that Na plus is one of the weak metals, so directly it will not turn into Na plus, however it will turn into H2 gas. So always the cation, if it's a weak metal, then it will turn into H2 gas, whereas the anion, if it is weak, it will turn into O2 gas. But here Cl minus is not a weak ion. If you want to remember more about this, please do go back to chapter 4, like topic 4. Sorry, not topic 4, to chapter 4. Topic 4 is about carbon, chapter 4 is about electrolysis. Like search chapter 4, you will find it. Now it is one of the strong metals, so it is gonna produce Cl2 gas. So the two gases that are produced when brine, which is NaCl salt, is electrolyzed, they are H2 gas and Cl2 gas. Now they want us to write the equations for the reactions that take place at each electrode. What are the two electrodes? We have the anode and the cathode. What you need to know is that at the anode, and keep this in mind, always at the anode, it will undergo oxidation. And oxidation, it is what? It is the loss of electrons. Whereas at the cathode, it will undergo reduction, and reduction, it is the gain of electrons. So if we were to write at the anode, what would happen? We know at the anode, the anion will go. What is our anion? Our anion is Cl2, okay? So it's gonna be 2Cl minus, okay, because it is strong. You remember that it is strong. So 2Cl minus aqueous, it will undergo oxidation, so it will lose 2 electrons and it will become Cl2 gas in addition to 2 electrons. Now at the cathode, which undergoes reduction, that means the addition of electrons, it will become what? We said that Na is a weak ion, so it will become H2 gas. So for it to become H2 gas, first of all, it needs to be water, so H2O liquid, okay, in addition to 2E minus because it undergoes reduction, so it's gaining electrons, it will form what? It will form H2 gas in addition to 2OH minus aqueous. So that is pretty much it for question number 2. For question number 3, they say write the equation of the reaction of hydrogen with chlorine. Now hydrogen, usually it's H2 gas. Okay, it is going to react with chlorine, which is also a gas, and it will form 2HCl gas. HCl is an acid, but because two gases mixed together, they will form a gas. So here they told us in part B, hydrogen reduces lead dioxide PbO into lead. Water is produced in the process. Write the equation of this reaction. First of all, hydrogen is in our reactants. It reduces PbO, which is also our other reactant. You should know that they said actually do not state the symbol, so without the gas. So H2 plus PbO will form what? It will form a water, first of all, so H2O, in addition to lead, which is Pb. So H2 plus PbO will form H2O plus Pb. That's pretty much it. We move on to question number 4. It says, list 3 common uses of hydrogen. 3 common uses of hydrogen. The first one is to manufacture organic compounds. So, manufacture organic compounds. Okay, the second one is synthesizing ammonia and hydrochloric acid. So, synthesizing ammonia, which is NH3, and hydrochloric acid, which is HCl. And then the third one is hardening unsaturated oils. So hardening unsaturated oils to make margarine. Okay, so that's question number 4 done. We will move on to question number 5. In question number 5, they told us which of the following is an industrial process for the production of hydrogen. Okay, here we have some extra information about the production of hydrogen. First, we know that it's the reaction between methane and steam. Second, we know that it's the electrolysis of acidified water. Okay, and third, this is new information, but the third one, which is thermal catalytic cracking of long chain alkanes, this is also correct. Because the alkenes, let's say for example, you went from C2H6, okay? You broke the alkanes and they became an alkene, because also the catalytic cracking of long chains of alkanes will produce alkenes. And let's say you had C2H6, if it becomes an alkene, it will be C2H4. So there is H2 missing. This H2 gas, this is the hydrogen gas. Okay, in addition to the electrolysis of acidified water and the reaction between methane and steam. Now we'll move on to oxygen. Okay, so to which group in the periodic table does oxygen belong? So over here, this is the periodic table. As you can see, oxygen in this group, if you count, this is group 1, 2, 3, 4, 5, and 6. So it is in the 6th group. And because it is in the 6th group, it has then 6 valence electrons. Okay? Now, deduce the number of valence electrons of oxygen. We just said like it's the 6th group, it has 6 valence electrons. Now, how do you test for oxygen gas? You should know that oxygen gas relights a glowing splint. So, whenever you have oxygen gas and you want to test for its presence, you bring a glowing splint, and if it relights, that means it is oxygen. Okay, so now we move on to question number 7. Write an equation to represent the decomposition of hydrogen peroxide. We know hydrogen peroxide is H2O2. Okay, it will decompose with the catalyst, which is manganese IV oxide, okay, to form water, H2O, in addition to oxygen. Now, to put their states, this is aqueous, this is liquid, and this is gaseous. And to balance them, you will put a 2 over here and a 2 over here. Now, the catalyst is MnO2. Write an equation to represent the reaction of oxygen with Na, Ca, Mg, and S. So let's see what happens. Na, it is a solid. It will react with oxygen gas. And let us see what's the product it will make. We will take their ions. We know it's Na plus and O2 minus. We do the crisscross method. We get Na2O, so Na2O. And so to balance it, you're going to put a 2 over here and a 4 over here. Now for the Mg, it's going to be Mg solid. In addition to O2 gas, it will form, if you take its ions, the ions, it is Mg2 plus and then O2 minus. You do the crisscross, you get MgO. Now you need to balance it. To balance it, you're going to put a 2 over here and a 2 over here. For Ca, it's going to be the same as the Mg, so it's going to be Ca solid plus O2 gas. It is Ca2 plus O2 minus. You do the crisscross method, you get CaO. And then this is a solid. And then to balance it, you're going to put a 2 over here and a 2 over here. Now finally, S. S is a little bit complicated. Now for the last one, which is S. S is a bit complicated. So S, it's found as S8. Okay, so S8 solid, it will react with oxygen gas to produce SO2 gas, and to balance it, you're gonna have 8 over here and an 8 over here. If you take it as S8. However, if you take it as S, it will be different. So I will put the other version up here. It could be S, which is a solid, will react with O2 gas to produce SO2 gas. So this is usually what we use. This is just extra if you want to know it, but this is mainly like what we use when writing these equations. Okay, so we move on to part B. Write two equations to show the complete and incomplete combustion of carbon. So the complete combustion, its product is gonna be carbon dioxide. So that's carbon solid. In addition to O2 gas, it will form carbon dioxide gas. The incomplete will form carbon monoxide. So that's gonna be carbon solid, 2 carbon solid. In addition to O2 gas, it will form 2CO gas. Okay, we move on to question number 9. So in question number 9, they told us complete the following table to identify the nature of each oxide, whether it's acidic, basic, neutral, or amphitheric. This is something that is from a previous chapter, which is chapter number 3, I believe. It is usually acidic when it's a non-metal plus oxygen. It's basic when it's a metal plus oxygen. Neutral is usually carbon monoxide. And amphitheric is usually PbO and Al2O3. Of course, there's others. You could remember them by going back to chapter 3. So, acidic, we said it's non-metal plus oxide. This one for sure. Basic, we said it's a metal plus an oxide, so it's this for sure and this for sure. We said neutral, it is carbon monoxide, and amphitheric, it is the PbO and the Al2O3. Okay, now question number 10. List 2 common uses of oxygen. Oxygen is used for respiration. This is one use. So it will give us energy. And also oxygen is used for the production of oxyacetylene. Okay, so just keep in mind that oxygen is used for respiration and the production of oxyacetylene. So again, 2 common uses of oxygen, respiration, and the production of oxyacetylene. Now we move on to air. Let me check how many questions are left. 1, 2, 3, 4, 5, oh my goodness, 6, 7, 8. Okay, we have 8 questions left. It's not bad, it's fine. Okay, question number 11. List 3 common uses of air. Air is a major source of raw materials such as oxygen, so it's a raw material source. Okay. How are the different raw materials extracted from air? Oops, sorry, I moved on to part B without completing this. Okay, the first reason is raw material source. The second reason is the combustion. So you will take oxygen from the air and you will use combustion. Okay. You will take the nitrogen from the air and you will put it in the fertilizers. But also another extra method is that you will take the noble gases and you will, like for example, argon and neon, and you will make bulbs out of like colored signs. So 3 common uses of air. First of all, air is a raw material source, and you can use oxygen to do combustion, nitrogen to make fertilizers, and the noble gases to make the bulbs. Now we move on to part B. How are the different raw materials extracted from air? Usually they are extracted by fractional distillation of liquid air. Okay, and now in part C, they said which 2 gases are the main contributors to acid rain. Usually they are sulfur dioxide and nitrogen oxide. So it's ONX. Nitrogen oxides or NOx. Okay, so just a quick recap of question number 11. 3 common uses of air. Air is a major source of raw materials, so you use oxygen for combustion, nitrogen for fertilizers, and noble gases for the bulbs. How are they extracted from air? You use the fractional distillation of liquid air. And finally, part C, which two gases are the main contributors to acid rain? They are sulfur dioxide and oxides of nitrogen. They are the main contributors to acid rain. Now we move on to question number 12. They said give the composition of air under normal conditions. Okay, here you should know what? You should know that 78% of the air is nitrogen gas by volume. Okay, 21% by volume is oxygen gas, and the rest being 1%, it is what? It is the carbon dioxide, the water vapor meaning H2O gas, okay, and the noble gases, okay? So keep in mind when they tell you the composition of air, 78% is nitrogen gas, 21% is oxygen gas, and 1% is carbon dioxide and H2O gas and the noble gases. Now, question number 13 is very important. They told us list some air pollutants with their sources and adverse effects. So, first thing we're gonna do is we are gonna make a table, okay? We'll draw a line like this. All right, so here it is the air pollutants. Over here it is their source, and over here it is their adverse effects. Okay, so the first thing we can talk about it is the carbon dioxide, CO2. Its source is from the complete combustion of carbon. So the complete combustion of carbon. And the adverse effects is that it leads to global warming. Okay. Then the second air pollutant we have is carbon monoxide. It's made by the incomplete this is the combustion of carbon, and an adverse effect of it is that it is toxic. Also, we mentioned. So yeah, again, we were talking about particulates. Okay, what about particulates? Particulates are also formed by the incomplete combustion of carbon, but particulates, they increase risk of respiratory problems. In addition to cancer. Okay, then of course we have methane. Methane, it is produced by the decomposition of vegetation. So I'm just gonna write vegetation, just vegetation. You will know that it's decomposition, and waste gases from animal. And its effects are that it also leads to global warming. Then we have the oxides of nitrogen, and being nitrogen, it's made by car engines, and its effects are many. We have acid rain, we have photochemical smog, and then we have the respiratory or breathing issues. Okay, and then finally we have sulfur dioxide, which is SO2. Combustion of fossil fuels, this is the source of the SO2, so combustion of fossil fuels. And what is their adverse effects? It's probably acid rain. So that's pretty much it for grid number 13. We move on to question number 14, top. The below apparatus includes a glass tube containing copper powder connected to a syringe. Syringe A holding 80 centimeter cubed of air and empty syringe B. The tube containing copper is heated while pushing A's and B's plungers for several times until the copper turns black. At the end of the experiment, the remaining gas mixture is collected in syringe A. The diagram shows the amount of gas remaining in syringe A at the end of the experiment. Knowing that the copper is in excess. Okay, so very simply, they told us what? They told us that there is gonna be a reaction between the copper, okay, and the oxygen. Alright, so there's gonna be a reaction between the copper and the oxygen. They told us that copper is in excess, and what is being the limited in this case? That means the limited, it is gonna be our O2 gas, or the oxygen. So first of all, we need to find how much is the amount of oxygen found in this container. We have 80 centimeter cubed of air. So very simply, we know that what? We know that around 21% of the volume of air is oxygen. So in order to find how much is not oxygen, because they want to know what? They want to know how much of the remaining air is located in gas syringe B. We know that the oxygen will react with the copper powder, and because the copper powder is in excess, that means all of the oxygen is used. So what will remain here is everything in the air except for oxygen. So first of all, we'll find out the amount of oxygen. That means it's gonna be 80 times 21%, or 21 over 100, and you will get that it is almost 16.8. This is centimeter cubed of oxygen. That means if 16.8 centimeter cubed of oxygen is used, how much of the air is gonna be left? It's gonna be 80 centimeter cubed minus 16.8, and you're gonna get an answer which is 63.2. If you round it, it is closest to 64, so our answer is gonna be D. Okay, so again, I will just explain quickly. We have a gas, which is air, okay? We have a gas syringe that contains 80 centimeter cubed of air. So it will pass through a copper powder, and we know that the copper will react with oxygen to produce something, which is probably copper oxide. I apologize for whatever that was. Anyways, so the copper oxide, we know that it's gonna form, but we also know that the copper is in excess. That means all of the oxygen is gonna be used up. If all of the oxygen is gonna be used up, that means the gas remaining over here is gonna be everything except the oxygen. So we find the amount of oxygen here. We found it to be 16.8 centimeter cubed, and then we would subtract it from the original value to get the remaining value, which is 63.2 centimeter cubed, and then we choose the closest possible value. We move on to question number 15. They told us clean air is a mixture of gases containing O2, N2, and CO2, and AR, which is the noble gases. 78% of this clean air is nitrogen gas, okay? Liquids and gases are separated from the mixture based on the difference in their boiling points. Always, whenever you see based on the difference of boiling points, you will know that this is fractional distillation. Always keep it in mind. Whenever you see the difference in their boiling points, this process is fractional distillation. Part C. Many pollutants like oxides of sulfur and nitrogen are formed from burning fossil fuels. Okay. Write the chemical formula for sulfur containing air pollutants. It's usually SO2. Okay. They told us why the gas containing sulfur is considered an air pollutant, because it will form acid rain. Of course, write it in full sentences. I'm just writing the key terms. So it will form acid rain. Suggest a method to reduce the gas containing sulfur from emissions of power stations. Here we learned this. Here we use the flue gas desulfurization. So in the flue gas desulfurization, we use the chemical that is either calcium hydroxide, so it's either CaOH, or it is slaked lime. Okay, so for part C, the chemical formula for sulfur containing air pollutants is SO2. It's considered an air pollutant because it forms acid rain. Now, a method to reduce the gas containing sulfur from emissions of power station, this is flue gas desulfurization. The chemical used is either calcium hydroxide, CaOH, or slaked lime. Okay? Okay, sorry for that, whatever that was. Amanda, please remember to cut this out. If I don't, guys, this is just a funny scene, okay? So now we move on to part D. In part D, they told us that catalytic converters are installed in exhausts of modern cars to absorb pollutants like oxides of nitrogen, carbon monoxide, and unburnt hydrocarbons. Name 2 oxides of nitrogen formed in car engines. Usually these two, they are nitrogen monoxide. Here they said name, so pay attention. When they say name, you will have to write it as nitrogen monoxide. Okay, and nitrogen dioxide. So keep in mind how the sentence is written. Okay, in part 2 they said carbon monoxide is formed from incomplete combustion of hydrocarbons like butane, C4H10. Write the chemical equation for the incomplete combustion of butane. Always incomplete combustion means that the product is what it is, carbon monoxide. So let me try to zoom in to write it. So the incomplete combustion of butane, first of all, butane we know it's C4H10. It will react with oxygen O2 to form carbon monoxide in addition to water. But as you can see, it is not balanced. So to balance it, I'll let you guys do it for like few seconds. I'll give you like I don't know, a few seconds, 20 seconds, let's say. Okay, so that's 20 seconds up. So to balance it, you will have to put 9/2 over here. In front of the CO, you will put 4, and in front of the H2O, you will put 5. Now, finally, part 3, what is the role of transition metals found in catalytic converters? Very simply, we know that the transition metals, they will act as the catalysts. Okay? Now we move on to part E. Carbon dioxide gas is absorbed from the atmosphere by dissolving in oceans and by another natural process X involving plants. Whenever you see plants and carbon dioxide, directly you should know that this is photosynthesis. Okay? Now, write the chemical equation for the process X. The chemical equation for the process X, you should know that it is 6CO2. Okay, it will react with 6H2O, all right, to give us C6H12O6 in addition to 6O2. Okay, so remember, carbon dioxide plus water will give us sugar plus oxygen, always in the presence of chlorophyll and sunlight. Now they said name 2 processes, one natural and one artificial, responsible for the emission of carbon dioxide in the atmosphere. One natural, it's probably respiration, and one artificial, it is the combustion of fuels. Okay, so that's pretty much it. Okay, so I believe that's part E done. We move on to part F. In part F, they said carbohydrates are polymers that break down by hydrolysis. Okay, and state the simplest product by the hydrolysis of carbohydrate starch. Always you should know that this is glucose. I don't know why they're putting this. This is more biology than chemistry, but yeah, you should know that this is glucose. State 2 ways to break down carbohydrates. To break down carbohydrates, you either add acid, okay, and heat in the presence of what? In the presence of enzymes. So to break down carbohydrates, you should either add an acid or heat in the presence of enzymes. Now part 3, partial hydrolysis of a given carbohydrate gives a mixture of sugars, okay? Now suggest a method to identify these sugars. If it's a mixture of sugars, okay, whenever you see mixture and you want to identify, this is very important, you will have to use what? You will have to use chromatography. Okay, that's pretty much it for this over here. We'll move on to question number 16 top. Rainwater is said to be slightly acidic due to the presence of carbon dioxide dissolved in it. The word of equation is carbon dioxide plus water is carbonic acid. The acidity of acid rain due to other pollutant gases in the atmosphere that also dissolve in water. Okay, what is the acid formed when sulfur reacts with the water? Directly it is sulfuric acid, okay, and its chemical equation is H2SO4. Name another pollutant gas that leads to the formation of acid rain. Usually it is the oxides of nitrogen, which is denoted by NOx, or even nitrogen dioxide mainly, so NO2. Now describe 2 consequences of acid rain. Some of the consequences of acid rain is that it corrodes metals, Okay. So again, it corrodes metals and like other buildings, stone, whatever. Also, they damage plant growth. So these are just like 2 consequences of acid rain. Of course, you could read the rest to get more information on it. So we move on to question number 17. The diagram shows a limestone column in industrial town. Limestone is largely calcium carbonate, okay? We have iron pins, column when first built, the same column after 40 years. Describe and explain the changes to the column after 40 years. In your answer, refer to the change to the limestone, the name of a pollutant causing this change, and the chemistry involved in this change. You can put, or you could say that over time, the sulfur dioxide and the nitrogen dioxide produced by the factories get dissolved in the rainwater. This forms acid rain. Acid rain will react with the limestone to produce, to decompose this limestone, and then finally the column will become eroded or it's being eaten away. You could say it like that. Of course, you can check the answers. You have more options over there. Now, finally, the last question. So finally, for CQD number 18 top, nowadays hydrogen is being used as a fuel for cars to reduce air pollution. Petrol that is used as fuel for cars is the major source of air pollution. This pollution can be reduced using the reaction below. So carbon monoxide in addition to nitrogen monoxide will form nitrogen gas plus 2 carbon dioxide. So where in the car does this reaction take place? Usually it takes place in a catalytic converter. Okay. Now, how is carbon monoxide formed in the car engine? Carbon monoxide usually is formed by incomplete combustion, always remember. Okay, now why does a hydrogen-powered car produce less pollution? Because hydrogen, the products of hydrogen-powered car, they are what? They are water only. And water is not something that will damage the environment. So you could write that hydrogen used as a fuel does not produce pollution or contribute to global warming because the only product of combustion of hydrogen is water. So that's pretty much it for chapter 2. Thank you guys for watching. I hope you enjoyed and have a wonderful day.